Hello, ladies and gentlemen. Welcome back to this series of Infrastructure Made Simple. I hope it is beneficial to you. Let's start with today's session. Till now, from the video one, we have understood one very important thing that whenever an application grows, a single or one server is not enough, right? That's why companies start running the same application on multiple servers. Yes, more than one servers are used. And this will definitely is improving the performance and reduce the risk of outages or downtime, right? But when we are doing this, there is a practical problem, and which is very common and very major. Okay, and what is that problem? If many servers are running the same application, how does each incoming user request know which server to go? Let's say there are 10 server, okay, and whenever you do a request, how that request reach to the appropriate server. I mean, let's say from that 10 server, server number 1, 2, 3, 4, 5 are very, having a very much load. Now, if that request again come to number 5, it means all this increase in bandwidth of infrastructure is a failure, right? Again, we are seeing the same latency issue because the server is now loaded, right? It is having a lot of requests there. So how this problem will be managed? So obviously the user will not do this manually, right? Okay. So to resolve such problem, we have a special tool that is known as load balancer. Okay, this modern system is known as something load balancer. Okay, so in simple words, a load balancer is like a smart traffic manager. Yes, it sits in front of your application servers. Okay, and become the entry point or single entry point for all the incoming user request. So now what is happening? Whenever a user opens your application, the request first reaches the load balancer. Okay, look at the screen. Everything is visible here, and it is not going directly to the server. So it is between request and the server. Okay, and it is deciding which server to choose and what all factors it is considering. It is considering which server is likely available or which server is less busy in case all are busy. Okay, so these are the some things which make the things better. Okay, so based on that, it forward the request to the most appropriate server. Okay, and from user's point of view also, everything feels fine, instant and seamless because now the most appropriate server means the server which is more idle as compared to other is now getting the request, and now the queue is not that much long and user feel that the request is working properly. Okay, so this is happening here. Okay, so this simple mechanism create a huge impact on the system performance. Obviously it is because now the workload is being shared instead of being dumped on the one machine. Okay, so as a result, what is happening? The servers are staying healthier, response time is also improving, and there is no sudden spike in traffic. Okay, because everything is now dealt better by the load balancer. That's why these load balancers are considered as one of the core building block, modern infrastructure world. Okay, so that's why this is very, very important. And this load balancer is smart as well. It has one more important benefit. Good load balancers continuously monitor the server health. Okay, and what they are doing, see the last one here, keep the server healthy, automatically bypass or slow down the servers. So what is happening here? If any server becomes slow or goes down completely, the load balancers are automatically stopping sending the traffic to that server. Okay, instead, what they are doing, they are redirecting the request only to the healthy servers. Okay, so this kind of act, this kind of smartness prevent full application outage and keep the user experience very much stable. Okay, so I hope you are getting it. Okay, so ultimately, the key idea that you have to remember that multiple servers help you scale, but a load balancer is one thing, is what making this scaling actually work in the controlled and the intelligent way. Okay, without load balancing, without the load balancer, the traffic distribution would be again chaotic and unrealistic. Even though you have a very huge infrastructure components, very great servers, very high memory, high CPU servers, but even then, if the traffic is not managed by an intelligent load balancer, everything will be in chaos. Okay. So in coming videos, we go deeper into how load balancers are making decisions and basically what techniques they are using to distribute the traffic so efficiently. So I hope you get it. Till then, thank you and subscribe to the channel. I hope you're liking the videos. Bye bye.